you, Chair.
Okay. Yes.
Yes, I am, but I just arrived. So we agree that.
Yes, shall I?
Can you?
Yeah, that's fine.
Yeah, just.
No worries.
Thanks.
Yeah. So you'll be the first speaker?
Yes, of course.
Perfect.
And you can talk, yeah?
Yes.
It's fine. So our questions.
Yes.
I don't know if there's any students tomorrow around the building.
No, we'll do that always.
Yeah. So, and I'll be in the room to help you if there's anything. Thank you. That's what I can do.
Yes, I will introduce you.
So the presenter should sit here in front?
I don't know how.
I think it would be easier to follow the presentation if you see it's just in the audience, right?
I think it's up to you what you want to do.
Maybe you prefer.
And I'll be handheld to whether you use the microphone or not. Okay.
Yeah. So I think we can start.
Yes, and everyone has to use microphones because everything's been recorded.
Yes.
You know, so to get the sound on the recordings.
Yeah.
Wojaczek.
Yes, I'm chairing the session. So if you want, because then it's easier to follow the presentation for you. So you, Thomas, I thought it's true for you as well. If you want to follow the presentation, it's easier to do that for the audience.
Okay, after the presentation, I go live?
Yes.
Yes, but it's better.
Ask some questions to the audience.
Okay.
Do whatever you want. Yep.
One moment, I need my...
Good afternoon, everyone. This is the session on data transformations, so that you all know what you are going to listen to. My name is Paul Smits. I'm with the Joint Research Center of the European Commission, and this afternoon we'll be going through a couple of presentations that highlight some experiences with data transformations in relation to Inspire. So, as a first speaker, I would like to introduce María Mancebo, and she will be telling about the problems arising from the implementation of the Inspire application schemas. So, I hope that we will not only hear about problems, but also about suggested solutions.
Yeah.
So, María, to you the floor.
Okay, thank you. Hi, good afternoon, everyone. My name is María Mancebo, and I'm working in the Geological Survey of Spain, to which I will refer to from now as IGME. The objective of this presentation is to share our experience in the implementation of the Inspire Directive, focusing in the application of data models and terminology. The problems we are facing and possible solutions will be covered also. What is IGME and why is IGME working in Inspire? IGME is the National Center for the Creation of Knowledge Infrastructure, Information, Research and Development, and in Earth Sciences, specializing in different fields of activity, such as geology, hydrology, mineral resources, and geologic hazards. This information is part of the Inspire themes. Therefore, IGME must assume their responsibilities in the implementation of Inspire Directive. It's important to know that this geoscientific information is supported by consolidated data models and terminology. What are the requirements of Inspire? Generating Inspire-compliant metadata, serving a spatial data set through network service, which conform to Inspire, and the harmonization of this spatial data set by offering the implementation of the specifications data. The later process on which this presentation is centered suppose involved to working with the implementation of data models and terminology. In IGME, 3 main tasks has been undertaken. The first one Oh, sorry. The first one was an analysis and comparison of Schema and inspired data models and data models at all levels, at features, attributes, and terms. The result was a definition of a data model integrating inspired and Schema data models. The second one was an analysis and comparison of Schema and inspired list of control terms. The result was a correlated vocabulary Schema inspired. Lastly, using the integrating data model and the correlated vocabulary was the implementation of a prototype. And now, what are we doing now? Schema launched a project for the implementation of Inspire Directive in the geoscientific information. The goal of these projects is to achieve the physical and effective implementation of data models and terminology. What type of problems did we find at this stage? We have classified them in two aspects. The first one is that Schema data models and vocabularies and Inspire data models and list of control terms are not coincident. A lack of conceptual matching has come to light. Differences detected require a process of correlation between features, attributes, and terms. The process is complex. It creates uncertainty and ambiguity, and shows that the problem is not a mere transformation of formats. Secondly, the potential dispersion of data sources because of the distributed responsibilities at national and regional levels. Here are some cases and examples of this. Case 1, lack of conceptual level matching features. The example is simple. Existing features on maps of Schema that they don't exist in Schema in inspired data model. The reverse is also possible. For example, the item planar structure represented by schistosity and bedding is considered in Schema essential for the interpretation of geological structure. This item has not been taken into account in the inspired data model. Here, the problem of the transformation problem is minor. It's not necessary to include this element in the transformation. But the opposite case is more interesting. The element borehole doesn't exist in the Schema cartography, but is part of the inspired data model. In order to comply with Inspire, we need to include this element in our transformation, but the process is not directly available. Case 2, mismatching at attribute level. When we compare the attributes of the same feature in one model and another model, they don't match. We can find several cases. An Schema attribute has a unique Inspire attribute. Okay, there isn't any problem. An Schema attribute must be divided into two Inspire attributes. Two or more Schema attributes correspond to a single Inspire attribute. We can see this in this example. In the hydrogeological data model, an attribute called aquifer media type has been established. This attribute doesn't exist in the Schema information. Schema experts have had to look for related attributes and combine them to fulfill the inspired requirement. Two attributes, permeability and lithology, has been used. This solution requires a reinterpretation of the original data. The process is complex and leads to uncertainty. New values may be less accurate. Case 3, mismatching at term level. Here we have the same problems. An Schema term has a unique inspired term. An Schema term maybe correspond with two inspired terms. Two or more Schema terms correspond to a single inspired term. Sometimes there is no correlation between terms, and in this case it's necessary to force a correspondence or accept a generalization. This is an important issue because terms play, or terminology plays, a key role in the semantic interoperability. We can see this case in the correlation process to describe the type and the grade of the metamorphism on the rocks. The same type of metamorphism, contact metamorphism, can be correlated with two different inspired terms in two different vocabularies. It's clear. The process is not straightforward. Case 4. The interpretation of UML databases that don't allow the direct election of the spatial objects. It's difficult, the problem that it's difficult to decide that a particular element becomes one or other inspired element. Let me draw your attention to this part of this slide. Oh, sorry. Here, there are two spatial features that represent the groundwater bodies, 1 and 2. One of them has been defined for the Water Fine Work Directive and belongs to other inspired them. This one refers to generic groundwater bodies and only exists in the geology theme. The problem is that in Spain, there are only groundwater bodies of the Water Framework Directive. Then we have different solutions. We can repeat this same spatial feature with different attributes. Therefore, we will need to solve a problem with the inspired identifiers. Or perhaps we can not put this spatial feature in geology theme, because it doesn't exist as such. Case 5, the uncertainty and ambiguity in the application of the inspired UML data models. The spatial object, fault, has only one attribute, the attribute profile type, with representing any of the two principal type of curvatures for dipping of stratified rocks. Okay? This attribute may be voidable. The problem is that if in the implementation of the application schema an attribute value is associated to this property, the geological structure may be displayed. You know what is it, okay? It's this case and this case. But if the criterion voidable is applied, this line doesn't provide any information, and the underground structure is unknown. Another application example is with the vocabulary of basic rocks. This vocabulary was published in the implementation rules, but the problem is too simple and doesn't contain common values such as sand, limestone, or granite. The problem is that this situation give rise to problems. Firstly, users will have overly generalized information, and secondly, there is an ambiguity when we assign these terms of the vocabulary. And the last case I am going to be covering today is the dispersion of the data sources that are part of the same inspired theme. State organization and responsibilities of the data may involve different providers at all levels concerning the same inspired theme. In some cases, even private companies are data owners and custodians. We can see this example in the slide. The core or manual resources data model comprises two spatial features classes, mineral occurrence and mine. In Spain, the problem is that IGME is responsible for the research on mineral resources. Data about mine and mineral resources are managed and controlled by different regional mining agencies. There are 17 in Spain. Other important information about mineral resources lie in hands of private companies. To conclude, there are problems with implementation of the inspired application schemes present at all levels. It has been demonstrated that the adoption of inspired data schemes require further development. Technical guidelines and implementation rules not fully ensure interoperability. And it is necessary to make the decision agreed by all involved parties in order to continue the process of inspired implementation. And the second is that a state organization may demand an expected effort to restructure spatial data set according to inspired requirements. We propose a solution that is to work in a development of technical guidelines for implementation or best practice or other. They are additions to the technical guidelines and the implementation rules. Their goal is to resolve all the ambiguities, uncertainties, and differences detected during the process of implementation of the inspired data models for each of the themes. The process must be agreed at national level by the different actors involved and at European Union level. This is all. Thank you very much for your time and thanks for coming.
Thank you very much, Maria, for these very important observations. Are there questions from the floor?
I think I'm fine.
Yes. Now you have to use the microphone because it's being recorded.
I'm Astrid Feichner from SDI Bavaria. I was going to come back to your first mismatch case.
I'm sorry, I was thinking that the ask was later. Okay.
Sorry?
Begin with the...
Okay, I think we can do it later. But my question was, I was going to come back to your first mismatch issue, saying that you have one feature class in your data model where there is no feature class present in the Inspire schema. Have you considered extending the Inspire schema, which is explicitly foreseen? Because you said that this information here is important to you. And that would be a means not to lose this important information in the transformation.
Our first work was to integrating IGME and Inspire data models and introduce this type of element. This is a good idea, but when you generate your GML, perhaps you can problems with the interoperability.
I mean, as long as you support the core Inspire schema, you can add things, and if you do that in a manner which is, I mean, it's not straightforward, but in a manner which is foreseen, then you...
If you have elements in the application scheme, perhaps you will be problems with the interoperability, because the GML structure is closed, and it's so difficult to put elements inside.
We've done that. I mean, you just have to extend a feature as a subclass, and I mean, not talking about validators, but that's a different thing. But it's doable. Okay. And you can also introduce your own code lists. In some themes, it's explicitly foreseen to do that, to add your own national code lists. As long as they're put somewhere online in a register, it works, usually.
Okay.
It's not straightforward.
This was our first part of work, integrating IGME and Inspire data models. But now we are working in the core of the Inspire data model.
Well, I was just sorry that I'm being persistent, but it's just that I hear that quite a lot, that we lose a lot of information going to Inspire, and that's a shame. I mean, of course, everybody starts with the core and the mandatory things to do that, but I mean, if there are means to actually get more of your source information to the target, then it's always a plus, I think. And if that's doable, then one should probably do it. Thank you.
Thanks a lot. I think we have to move to the next presenter. What I would like to highlight, though, in the context of the transformation between national and Inspire schemas, is that the GIS for EU project a few years ago developed a classification schema to characterize the accuracy by which this is done. And this would be something that we can come back on later.
And okay, move to my presentation. I think it's the second one normally. Yes.
Yes.
Just as it took subjects, what was the schema about again?
That was the GIS for EU project that developed a classification schema to characterize the accuracy with which matching is taking place. And that can be very useful in order to have a global characterization of how accurate and how precise this transformation is. Very good. Now we go to the next presenter, Dominique Laurent from IGN France, and she will tell us about the design and use of the matching tables to prepare schema transformations. Dominique, to you the floor.
Thanks. So what is the context? IGN is a national mapping agency. We have many data, many themes, many levels of detail to be made compliant with Inspire. We have decided to adopt a two-step approach. In the short term, we will use our existing data and just make it Inspire compliant through transformation schema. First on sample data and then on the whole territory. And in the long-term approach will be to make some evolution in our products to make them closer to the Inspire model and maybe to allow on-the-fly transformation. But at the time we are not so advanced. We have considered several themes until now in the short-term step: administrative unit, address, geographical name, transport for road and railway, cadastral parcels, and hydrography. So the first point generally is to use matching table to prepare schema transformation. It's the first step. How to design this matching table? Generally, it's using Excel. It's not very advanced technology. It's very simple tool. On the left side, there is the Inspire model. On the right, maybe I should On the left, the InSpy model. On the right, the source model. And just in the middle, the transformation. One of the issues is to derive, I will say, the left part in a semi-interactive way from the UML model and from the code list and so on. So, some example, geographical name, there is a feature type that is called nameplace that has several types of attributes. Some attributes are, I will say, basic attributes defined as character strings, as numbers, as date, as Boolean, as geometry, and so on. Some attributes are more complex. They are defined as data types, attributes composed of other attributes, sometimes themselves composed of other attributes. And there are also some other typical attributes, those that are defined as enumeration on code list. Why are they specific? Because generally the matching has to be done not only at attribute level, but for each value, each possible value of the attribute. So, the transformation has to be done at atomic level on these simple attributes, such as date, time, geometry, numbers, character string, or even at the values of the code list. The transformation cannot be done directly on the data types. So our matching table, one principle is that we have 3 sheets for the matching table. The first one, maybe you think it's a triangle, but it's not a triangle. It's the trunk of a tree. It's the feature type. On the trunk, there may be direct attributes, such as character string, numbers, geometry. You can have also, on the branches or on the data types, you have other attributes that may be also simple ones. So it's why we have this second sheet. And we have also the enumeration on code list. So one sheet is for the main correspondence between the feature types and the direct attributes, the green attributes. The second sheet is for the attributes that are in data types, the yellow leaves. And the last is for the attributes that are defined as code list or enumeration, because we have to define the correspondence for each value. Still the geographical name example. These attributes, they may come from different sources. They may be very basic attributes or even data types that are defined in the application schema of geographical name itself. But there may be also some data types such as the identifier that are defined in the generic conceptual model and in a package that is called base type. Another example, there are the code list. They are defined in the geographical name, but not in the model itself. Another example, it's about this least detail viewing resolution and most detail viewing resolution. It's defined as MD resolution. It's a data type coming from ISO 19115, but really it's a data type that is quite simple, that has not so many branches. We have chosen to implement only the equivalent scale, so we have decided not to really import the data type, but make it simple in the transformation. Just documenting equivalent scale equal 5,000 or 2,000. So at the end, to prepare the matching table, we have to go to look at the data model of geographical name, the code list of geographical name, but also to go for the data type identifier that is in another package. And importing all these things in Excel, we can design our matching table. I will say in a semi-interactive way. Of course, Excel imports automatically the concepts coming from the UML model, but we have to structure it in our 3 sheets. Another example, not yet, the result for geographical name is this kind of matching table. It's just a matching table template. It's something quite handleable. It's not so big, and really it's not so difficult. So it's the correspondence sheet for the feature type and the attributes, and here it's for the data types. And we have a third sheet for the enumeration. Something a little more complex is the transportation road example. It has 3 levels of inheritance. It inherits from the common transport and even upper from the generic network model. Other characteristics, the transport properties as considered as feature types. Among these properties, there is the road name, and the road name is defined as a geographical name, itself defined in another theme in the geographical name package. Other example, some attributes use the CE citation that is once again coming from ISO 19115, but this data type is not simple at all. It's not as a MD resolution, it's quite a complex one. And as it was quite complex, we had to include it in our matching table. And include this data type means including almost 50 additional lines in the Excel table. So to design this table, we had to make a lot of things, to import the data model coming from common, I will say maybe from the beginning. The upper level of inheritance is the generic network data model and code list. Then what is the common transport. Then what is specific to road transport. We have also, of course, to import, for instance, the identifier from base type. We have to import the geographical name from the geographical name package. And we have also to import the CE citation from ISO. So it's quite more complex. We have more things to be imported. The result, we have this part of the matching table. We have also to take care because in the transport network there are instantiable feature types and there are also abstract feature types. So on the I say very left part we keep only the instantiable feature types, and on this column we indicate the inheritance. It's useful because if the same instantiable feature inherit, if different instantiable feature inherit from the same parent, likely there will be common matching rules and we can do some copy-paste. Other point, we tried to order our matching table. I know, for instance, in previous projects such as SDIN, it was automatic import from the application schema, and the feature types were ordered by alphabetical order. To make the matching, maybe it's not the most user-friendly. So we decided to order them first, I will say, the real special feature types having a geometry. Then we put the properties, for instance, the properties common to steam transport, and then the properties specific to road transport, to make some ordering in the, I will say, some semantic ordering in the matching table rather than the alphabetic one. Okay, now the use of matching tables. There is a lot to be said. I will choose only very few examples. First, some context of use. For each theme, we make meetings to fill the matching table. The table are prepared in advance. The template is prepared in advance. And the contributors to the meeting are very classical. People knowing InSpy, people knowing the source data, people knowing the transformation process. It's not very specific to us. First example is about the scope of geographical name. in IGN, we have, I will say, a theme that is called point of interest. For us, it's more or less our geographical name theme. But in fact, we have also feature types having name in almost every theme. A river has a name, a road may have a name, an administrative unit has a name. So our decision was taken to provide for Inspire all features having a name. Consequence number one, it was that we had a lot of source features coming from different feature types with different structures, with different attributes. So the matching will be quite different. It's why we have decided to have not one matching table, but 3 matching tables, because it was too difficult to handle everything in one table. So we had a table for the point of interest, a table for the administrative unit, and a table for what was network, road, hydrography, and things like this. Another consequence that may be of interest, maybe for all of you, at least some of you, it's about the identifier. We are lucky enough to have persistent and unique identifier that are called CLEAPs. It means absolute key. And for the namespace, our initial idea was just to follow the generic conceptual model by the country code, the producer, the product. FR, IGN France, BD units, our product. But we realize with geographical name that the same source feature may be present in different Inspire theme or sub-theme. For instance, a river will be in hydro-physical waters, it will be in hydro-network waters, it will be in geographical name, it may be also in transport waters. So we needed to make distinction on the identifier, because there will be, for instance, for the river, 4 different features. Maybe it's a real-world entity, but the Inspire identifier is about the feature in the dataset. So we decided to add the name of the Inspire application schema to the namespace. And in addition, we realized that our identifiers were unique only by territory. For instance, in France, we have metropole and overseas departments, so we had also to add a suffix according to the territory. But really, I think the most important point is the second one, because you may have the same issue. About the second example is about properties of theme transport network. For us, we have some feature type that is called tronc route. It means road link. We have a unique identifier. Once again, it's this absolute key. And we have direct attributes. It means, for instance, the number of lanes is an attribute of the road link. It's not a specific feature by itself. So we had to provide identifiers to these properties, because in Inspire, the properties are considered as feature type. So the idea was to, we have kept the same namespace as explained a few slides ago, but in the local ID, we have identified the property using the absolute key of the road link and adding the name of the property to make the identifier unique. By doing so, we have implicitly considered that what was making the identity of the property was its location. Another issue is how to reference these properties, in other words, how to make the association to the related road link. So what we have decided is to indicate this association in a way by using the Inspire ID of the road link. But as we cannot use the Inspire ID itself, what we have made is a concatenation of its component. For us, we have only the namespace, that is here, and we have added the local ID here. So we use the Inspire ID of the road link to make the association between the property and the road link. In this case, it's just an editorial remark, as the rule was absolutely the same for all the properties, we could make some factorization and we didn't have to duplicate every time the same rule for all the properties. Another example, still on SIM transport network, there may be properties, typically the condition of facility. This condition of facility may apply to different feature types. For us, for instance, it may apply to the road link, but it may apply also to the road node or to the road service area. So in this case, we have to duplicate in the matching table all the lines corresponding to the condition of facility. I think that is for the examples. The conclusions. The matching table is a key document. It's the starting point for the transformation process. It helped to capture the decisions that was made, and of course it helped to initiate the mapping on computer. But it's also the starting point for further activities. For instance, it's important for the data validation, how to ensure that your data has been transformed according to the rules you have defined. It's also a key point for data documentation. When we will supply the data to users, we have maybe to tell them the rules we have taken. And of course for the evaluation in future. The matching table, generally they are accompanied by meeting minutes giving the rationale for choice when there have been discussion, when there are conflicts, different options, when we are not really happy about our mapping, we document it. And all this imperfect matching that have to be documented, reviewed, and maybe helpful for us to make evolution in future to get our product closer to Inspire. There are some points that are not addressed in the matching tables. For instance, HTTP URI identifiers. You have seen from my namespace that we are still old-fashioned. We have not moved yet to these HTTP identifiers. We are expecting more guidelines. We have not considered association between SIMs. Why? Because it's difficult to know the identifier of the target object before you have dealt with the target SIM. So we can do it only once all SIMs have been considered. And there are some common issues to all SIMs. For instance, how to deal with GML identifiers, how to deal with localized character string. We deal with these issues, but not in the matching table. It's done elsewhere. Some conclusion also, schema transformation rules must be defined at atomic level. So on feature types first, on basic attributes, and if you have code lists, sometimes even for each value of the attribute. The point is to make the transformation rules as clear as possible. If you need to duplicate the feature type or the data type line, if the transformation rules are different, don't try to explain everything in this part of the matching table. By using as much as possible a standard language, we have tried to use something close to SQL. And if there is some transformation that may be not so obvious, for instance, I think this transformation is not really understandable by the public, it comes from Postgre syntax, put comments to explain it, to explain what the transformation is supposed to do. Make it easy because the transformation people need clear guidelines. And even if they contribute to the meeting, after some weeks they will have forgotten or confused with another theme. So the last slide, filling matching table is like sport. If you have some training, it's better. We make tested in Annex 1 and we get benefit from it. Of course, we began by the simplest theme. You have also to keep calm. Maybe Excel looks simple, but in fact, manipulating Excel table during meeting sometimes is quite irritating. Keep concentrate. because you don't have to forget any attributes, any of the leaf of the tree. You have also to make consistent decisions, and it's not so easy. Be resistant also, because some seem may be quite long to be dealt with. And of course, you have sometimes to be clever and flexible, because there are some really complex transformations. And as sportive, you can be also proud of yourself. And I will show you, for instance, this transformation. Maybe you cannot really enjoy the beauty of this transformation, but for us, we are very proud of it, because it was our masterpiece, implying many source tables, semantic and topologic relations. And we are as proud as a skater after triple axel or a double salto or some acrobatic figure. So many thanks.
Thank you, Laurent. While the next speaker is setting up, there's time for a question or two. First Paul and then Martin.
Yes, thank you. My name is Paul Janssen from the Netherlands. Dominique, my question is about the irritating aspect of Excel. You're right, of course, that this is a starting point for doing schema transformations. Do you have any experience with software on the market or software in the open source community that is helping you doing this? I had a conversation with the former Humble program that have, well, developed schema transformation tools. Do you have any experience with similar tools?
Of course, we have experience about tools making the schema transformation. For instance, we are involved in the ELF project, and we have asked some help from Snowflake, and I will say I was rather surprised, because we send them our matching tables that are not simple at all, and apparently they could deal with them without asking us any questions. So maybe our matching table were good enough, but I don't know any other software as Excel to document in the first step the transformation.
Okay, if I just may ask one simple question. I'm quite happy to see that you point out the importance of using of name of application schemas in identifiers. With that, are you planning somehow to use this functionality of INSPA registry, particularly a register for application schemas, to actually use this functionality for your transformations?
I'm not sure I understood the question.
The question is whether you are planning use the services made available through the INSPA registry. There is one register called application schema registers, and I was wondering whether you already thought about using this service for the transformation.
No.
Or you didn't thought so far, yeah?
No.
Okay, thanks.
Not yet.
Okay. Thank you very much. I think it's time to move to the next presenter. So Thorsten and Simon will ask us a question. Are we ready to transform? And I guess that you are going to talk about solutions for data transformations. So to you the floor.
Yeah. Thank you very much, Paul. Yeah, so when I just saw the two presentations before, I thought, yeah, okay, these are problems that we've also been encountering and that people told us they have. And there's one specific aspect that I'm going to tell you a little bit about how we could address that together. Okay, so very briefly, two thoughts that have been guiding the work that Simon and me have been doing in the past years were, first of all, one thing that we already discussed in the Humboldt project like 6 years ago, a core idea was, how do we actually reuse components and solutions and so on? Because we are in a world where there's so much custom stuff that we also have a hard time learning from each other and exchanging practices, because everybody has their own brew, essentially. And the other thing that we also always thought about is, okay, so taking this into account, what could a data transformation platform look like that would enable us to do these things that we're encountering in a more collaborative and simple fashion? All right, so let's have a look at some of the kind of environmental things that we encounter and that we've been seeing. So one thing is we're dealing with a really, really large amount of complex data models that we are trying to get data in and out from. This is just a count from the current Inspire and OGC data model sizes. So if you look at it, we have in the OGC and in the Inspire repositories about 2,000 complex types each, and that's just the latest version. That's not taking into account that you might have implemented something against any of the earlier versions. And of course, there's lots of property elements and reference elements and so on. And this is growing rather fast. So if we look at how many elements there were, unfortunately I only had snapshots for these 4 time periods, otherwise I might have made a nicer curve. But you can already guess that there's a steep upward going curve. And my feeling is that with Inspire, now that people actually start to implement it and start to make extensions and so on, we are not yet at the end of this curve. And OGC is also alive and kicking, as they say. So there's a lot of activity going on there as well. So what we can see is that we have a really big data schema model size here. And the question for me is, can our tools actually keep up with that? Do they scale with these kind of information models? And yeah, so the second aspect of that is that the whole transformation project work is actually pretty hard. So one shouldn't forget that effectively whatever tool we are using, we are effectively doing a programming task. We're doing ETL kind of work, we're transforming some data that we get in, we're making all the decisions that you would typically make in some program. And often this looks like programming, so the above example is from an XSLT sheet that was used in a data harmonization project. There's a Humboldt example, Hale example sprinkled in between. Then there's other tools that you can use that all create the kind of same complexities. And especially, I've given a lot of workshops on the topic, and when you see the people, how they use the tools, you quickly realize that they will find a solution. They always find a solution to bring the data in, but it's not necessarily optimal or robust or transferable or reusable. So I was really wondering, okay, so what's the reason for that, and what might we be able to do about it? And then there's another thing. So something like the Excel tables, which we've just seen, is actually quite good because it kind of abstracts a bit from the concrete problem. But on the other hand, it doesn't really give you feedback. You make decisions somewhere in the sky, essentially, without directly knowing, okay, what will this look like in the actual data that we're working on. And at the same time, immediate feedback is something that's really, really important to help understanding a data model and how things behave in that world. So if you think, for example, of engineering. Engineering nowadays, like here in this case, a lot of things are done interactively. So you have a system that enables you to update, let's say, the shape of this blade, and you'll directly, interactively get an updated airflow around it. And this helps enormously to understand complex problems. And so another thing that we've always wanted to achieve was to make whatever tools we're doing interactive so that you have a much quicker learning curve on this topic. The other dimension, in addition to this real-time feedback, is that you can also learn a lot by feedback you get from colleagues. And this is done, for example, if you sit around a table and create a matching table. Then okay, you get the direct feedback. But unfortunately, you can't sit around a table all the time. So you go down to implementation and you find this additional problem that you didn't think of when you were sitting together. And then you also want to have feedback, and you want to have it maybe not in 6 months, but ideally tomorrow. And that sometimes makes it a bit hard. Yeah, so then the final aspect, and that was something that we researched throughout Humboldt and later, was we also always wanted to know, okay, so if it's hard and it's complex, do we actually really reuse stuff, or do we just essentially sit at conferences and discuss best practices and ideas? And from the data that we have, it's in part pretty old already, so 3 years old. It might have improved since then, but back then the trend was clearly that there's only very limited reuse. So there's special software, special configurations that's used for, essentially for data transformation, data harmonization, and so on. But it's not really reused a lot. It's slightly worse even with the process definition. So if you think of the Excel table that we've just seen as a process definition, where somebody has defined what needs to be clearly done, then these are currently really almost not reused. So we have a case where there's a lot of effort going into these resources, and they're actually created again and again and again, instead of looking what kind of parts might actually be valuable to all of you. So for example, how could Dominique provide parts of her tables in such a way that you could actually start your work from them? That would be the question to answer here. Yeah, so taking this into account, you see there's a few reasons why we think that this is an area where it still mandates a little bit of scientific and technological work. One thing is the more or less increasing, exponentially increasing complexity of the world that we see with data sources, data volumes, and also the variety of data. Another thing is this whole area of getting immediate feedback. And the final one is that we have a limited level of commodization of the solutions. And there's a few things that we've been working on to do that. So with the complexity, it means reduce focus, essentially. So what do you really need in terms of information at any point in time? Also increasing the accessibility, so how easy it is to use the tool. That is the prime reason for using Excel, because the hurdle is relatively low. For understanding, that's essentially collaboration and interaction. And for the commodization, the most important part is breaking solutions into the smallest possible parts where they make still sense and giving this to a community. Many of the things that I've been talking about have been implemented in the Hail open source software for spatial data harmonization that we've worked on in the last years, and that I know some of you know. Dominique had also been involved in the project and given us important tips about how to improve it and what she might need. And yeah, this, as I said, implements some of the stuff already. For example, this declarative model allows us splitting a complex work into individual nice atoms. However, what's kind of missing from this is still the collaboration part. And that's something we would like to show you something new. So we have worked on a new platform called WeTransform2. And we'd like to show you how you can collaborate on this platform to solve, let's say, in this case, maybe not that hard mapping problem. I'm not sure if this one is on.
So, can you hear me?
Okay, this one.
Yeah. So what I'd like to show you is, I've just have a mapping project here that I created in Hail together with someone from Italy who knew the data, and I just want to go shortly through it. What we saw before in the presentations, okay, where are correspondences between feature types and attributes and so on. And in my mapping here, I can go to correspondence between feature types and see how we did define them in Hail. So here's the feature type correspondence, and now come the correspondences that are on the type level, on the attribute level. So now with this project, I created it with someone else, but there's still some things I'm not sure about how to handle. So I will create a task here for this project, because here see, okay, I have here attribute code tot that I'm reclassifying to Inspire code list here in the Hilux land use in the zoning element. So it's project is in the topic of land use, planned land use, and here you see what I already did. So here's what the target values is for my specific source values. So it's a kind of number representation of a classification. But what I'm really not sure about, you can see it below here, is what should actually be a default value for now. If I don't have classification defined here, what should be the default value? So, and the Hilux land use, it describes there are two values that I think could be appropriate. So my question will be, okay, what to use as a default value? And I'd like to know, I think it should be other use, so referencing something that's not in the code list or not known use, but I'm really not sure. And I hope there's someone who has a good answer to that.
Now, notice that this task was assigned to the group Inspire Land Use.
Okay. So yeah. So someone else.
Yeah, and I'm part of that group, of the land use group. So on my view of the page of the platform, I can actually go to the group land use and see, okay, Simon created a task. Let me see what he's unsure about. Okay, whether to use other use or non-known use. And now I might not be a PLU expert, but I might have read the specifications and know a bit about them. So let me look at that task. Okay, so I can take into account the context of this, understand that it's trying to perform a classification mapping here, and I can create a solution. And for this solution, in this case, I will actually confirm that use null is a very good approach, because, let me just copy that, I'm a bit lazy in typing from here. And essentially the idea is that, actually using unknown or using other wouldn't be correct. Other would mean that it's a known value, but we actually have, we don't have a known value in this case. What we want to achieve instead is that when you validate your data, you get a notification that the data set is missing something, the source data set. So I save the proposal, and that's it. It's now being sent to Simon again for review.
Yeah, so I can do now, when I get a notification about a task solution, I see and in this case is the proposal for what I should, how I should configure my relation here, my correspondence in that case. So okay, in that case there was no change because I was unsure before, I had nothing selected here. But if there were some changes, I could just say, okay, I would apply the new settings to my project, and when this is done, go to my project. I will see that it's adapted, and then I could use it. Either load it in Hail again to actually perform the transformation, or use the platform to generate the transformation service.
Okay. Okay, so that's one of the processes that we thought about. So quickly summarizing, the idea is that you collaboratively use the strengths of everybody and the knowledge in certain groups to quickly get to a good solution. And there's some other things that we've been working on. For example, for the problem to extend a schema, there's also a hurdle there, a certain tool hurdle, and that's something we're going to add here. So you will also be able to manage and extend schemas on the same platform using similar tools. And data publishing, well, if you've defined the transformation, it's a very short step to actually just publish this as a service. There's a lot of tools that we'll provide for that, including managing and sharing these transformation projects online. Referencing the whole versioning and maintenance thing is a really important consideration to us. So if a schema has a new version, you'll get a notification for all of your projects that there's a new version and that exactly these three elements have changed, and that this is what you need to provide as a differential update, so to speak. And of course, I'm a big fan of nice visualization, so you'll get some really new schema visualizations as well. There's also some specific things that we worked on for Inspire. One thing is I have to work a lot on applications that only support simple feature style work, and then you will want to have something that flattens them down according to certain rules, so that you can directly use the software. And we're also working on extended validation and repair mechanisms within the platform. So you've seen, maybe for those of you who know Hail, know that it has quite a powerful validation engine inside to perform validation on the fly, and this is the basis for this. One thing that I'd like to notice is that we'll make two models for this. One thing is essentially you're an individual, you want to use all the tools that we've shown you. And the other side to this is you want to enable a whole group. So let's say you're head of a working group and you want to ensure everybody can use this, then the second level would be for you. Okay. Yeah, that's more or less the 15-minute tour through WeTransform 2. As I said, it's a platform that we are using to complement the work we've done before with Hail. And if you're ready to join and to see how this could enable you, then please visit the site.
Thank you very much. That was a very fast and precise overview of your new developments. Is there a question? Olaf.
Yes, hello. Olaf Pieters from the Belgium Interregional Environment Agency. Yeah, very interesting development in my mind. They're really up to the task to combine efforts online. But how would you, now with the current version, how would you get the data out of databases which are maybe behind some firewall? Would you, at the moment, is it still in the stage where you need to export your data in some form and then upload it to retransform to?
Well,
or,
the alternative is essentially using an on-premise version of this, but we'd have to discuss that.
And connected to that, if you have your data transformed, can you make a service out of that, or is it you only export some type of data?
So you can make a service out of that directly.
One more thing about the data. So you can the schema transformation project in itself. You can also share without any database access, without the data. So just the schemas and the mapping. So you can work also with that if you have the problem that the data is not available outside.
Yeah, something that I would like to add to that is you can also have, if you do upload data and you want to have help, you can also tell the other person they only get statistics access, so they didn't get to more or less the validation output, but the data is never transferred to them. So there's different levels of how this could be dealt with.
Thank you very much. We now move to the next presentation that will be given by Darja Lihteneger from the European Environment Agency. And Darja will explain us how the Inspire data specifications have been implemented in terms of transformation workflow, and the related challenges will be explained.
Thanks. Thank you very much. European Environment Agency collects quite a lot of data sets from countries through different reporting data flows. And recently we started to think we need to understand better how this transformation workflow should actually be designed, which will guide us for the transformation of data sets based on the Inspire data models. And for this purpose, we used one of the important data sets. So today I will present you what was the purpose of our prototype, what kind of transformation workflow we designed, and what kind of tools and outcomes we have in this transformation workflow. The few of the open issues that we found, and they are still open to solve them, and what are our expectations, what can be done to speed up this data transformation workflow. So the prototype is oriented on one of the databases called Common Database on Designated Areas, which is European inventory of the nationally designated areas. Those are those protected areas which are designated under national legislation. This inventory is relatively old, started in 1995, and all the versions since then are kept. It is also one of the IEA IONET priority data flows, which means that more than 30 countries contribute data. This is voluntary agreements to report the data on an annual basis. What it is important is that CDDA is also included in the United Nations World Database on Protected Areas, and therefore with this data flow covers national, European, and global level. So, this is our thematic scope. Why we need this prototype? We want to explore the transformation workflow, tools, and feasibility. And we want to share this knowledge within the IONET community to see how in the future we can have a harmonized and Inspire conformant data flow. First, a little bit the basis for transformation. So Inspire directive defines that the spatial data set should be made available in conformity with the implementing rules, either through the adaptation of the existing spatial data sets or through the transformation services. The transformation workflow should be very generic. The transformation workflow, which will be actually a workflow to transform the data, should be very generic and applicable to any spatial data set that will have to be transformed. So in our case of our prototype, we are using this workflow designed in this prototype to transform the existing European CDDA data set with regard to the Inspire protected sites. The transformation workflow has 6 steps. The initial one would be the identification of the source and target data models, and if needed, to explore if both data models are actually developed, or there will be a need to provide a simple data model. The step 3 is the heart of the thematic of the content mapping, the so-called conceptual mapping, which will provide clear mapping rules to transform from one data model to another and to clearly document what these rules are. The data transformation step 4 is pure transformation based on the mapping rules into GML files. The step 5, we need to have some sort of validation and testing of GMLs. So the main question here would be, is now GML in conformity with Inspire implementing rules? And as the last step, there should be a way of how to publish the GML files. Now let's go slowly through these steps and see what kind of experiences we learned in our prototype. So in the step 1, we started with the initial study, and we identified the source and target data models. This initial study is more top-level analysis of characteristics of data models and other requirements, so both data models and requirements from both specifications, but also to better understand the characteristics of the source data sets, and to identify already the potential gaps and uncertainties that might exist between both data models. In the case of our prototype, we identified as a source data model our European CDDA, and as a target Inspire protected site simple application schema. And the initial study already showed us some problematic topics. One would be uncertainties with an interpretation of some Inspire concepts with regard to the CDDA concepts. Is it enough that I follow only the Inspire protected sites data model, or I would need some sort of extension to preserve the purpose of the CDDA? And also what we found dealing with the European data sets was how to deal with large data sets, with large size data sets. So our CDDA data model is a set of tables with several attributes, and we identified only a subset of related tables and attributes that will be used that corresponds to the Inspire protected sites application schema. The Inspire protected sites application schema provides a limited set of fundamental attributes, which are usually provided in a more complex data types, like it is example here with the designation, here, with a designation type. Step 3, after this initial identification of certain difficulties that we might face, we have to go back into a profound content discussion with the thematic experts to clarify all the concepts of the CDDA and the Inspire protected sites. We had to do the very detailed comparison between both data models. This means at the level of feature type, attributes, code lists, formats, and what to do when we don't have data in our CDDA. Based on all this analysis, we build the logical mapping rules between both data models, and we check the mapping rules with the existing data from the source database. And we provide a detailed documentation about our findings and the reasons for our decisions. So the tools that we used in this conceptual mapping was actually the matching table. which is very similar one to those that we have already seen today, which provides the inspired data model and the corresponding, the matching with the corresponding tables and attributes from the CDDA data model. In addition, what we provided, which this table includes also the rules for the mapping, but in addition, not only to provide short expressions, we provided a complete guidelines of the mapping rules with exact information how the mapping should be done, how to transform the formats, what were the reasons for our decisions when we had the different dilemma. And both of these documents are actually the basis for the next step, which is data transformation. The important thing here would be to select the appropriate software tool which will be used to transform the data. The next thing is to embed the mapping rules, the logical mapping rules from this matching table and guideline document into the software, because this will preserve you that you can rerun these mapping rules again on the new version of the data set. What was important here, that this was the place when we started to use more directly the Inspire XSD schema, Inspire Protected Site Simple Application XSD schema. And if it is necessary, you will have to prepare your data sets to be imported into the software tool if this is needed. So with the selected software, we managed to build the logical mapping. We imported the data set, and we transformed the data sets into GML, and we used the embedded validation functionality of the software tool. So examples from our prototype software tools used were GeoConverter developed by Tracasa. We were using Hail Editor and some other XML tools like Oxygen, XML Spy. And as the input file, we were using the shapefile. So in Hail Editor, our mapping rule that you have seen in step 3 in a nice Excel table and in the guidelines document are actually now encoded here, embedded here. On the left side is our input shapefile. On the right side is Inspire XSD schema, and here are the logical rules. A lot of times we had to combine, sometimes the attributes could be mapped directly, it is just practically the change of the name of the attribute. Other times we had to combine several attributes from CDDA to provide one attribute that corresponds in Inspire PS data model. Or we had to build a logical condition saying, if my data in CDDA doesn't exist, please provide this voidable reason. So all of these things were possible to do in Hail Editor. And as a result, when this was embedded, a function of transforming data gave us the GMLs. And this is one example of the GML encoding of just one polygon, not complete GML. So we have GML, we have transformed data, we have GML files based on Inspire requirements to be sure to be in conformity with the Inspire implementing rules, what to do with the validation. Here, this step in the workflow is extremely important, but it's very difficult in the current situation because of several uncertainties. Actually, how to perform the validation tests based on the abstract test suites in the Inspire technical guidelines in general. The Inspire abstract test the abstract thesis for Inspire Protected Site has been just recently published in the updated version of the Inspire Protected Sites. And the abstract conformance classes are actually not dealing only with the data, but also with the relation between data and metadata, the view services. So, and it includes a lot of different tests for which we will probably need several different tools to perform them. However, a certain level of validation was already embedded in Hail Editor, so we relied on these outcomes. But we also noticed that to perform all the abstract test suites, we would need additional capacities to develop additional tests, and this is for additional tests needed. So we are actually, our prototype is actually in the phase to work on these validation issues, and what we propose as a simple validation step would be just test GML against the XSD schema and try to import GML into GIS software, see if the results are actually as you expected. What will we do more in this, our prototype will be more theoretical evaluation, how to execute the abstract thesis from the Inspire protected sites, and what kind of tools could be used to do this work. And we would also like to demonstrate few selected tests, not everything, not all tests from the Inspire protected sites, but only few selected ones. So, summary of our transformation. At the level of the conceptual mapping, what we proposed at the end was to extend the Inspire protected sites data model. This is a recommendation. To keep the purpose of the CDDA and to provide the national designations categories which are currently not included in the Inspire protected sites data model. We found also some conceptual differences between the understanding of the Inspire protected sites attribute legal foundation document, which requires the legal act which creates protected sites. In the CDDA, we are dealing with the legislation which supports the designation, establishment of the designation categories. These concepts we found as non-matching, and we didn't map this attribute. We propose to map it as voidable element. We also found that some Inspire protected sites attributes could be provided by default values. We don't have those values in the CDDA, but from the purpose of CDDA, certain default values for all the records in the CDDA could be used. And what was also necessary was to make the mapping between the ISN categories code list, because Inspire uses the keywords for the type of ISN categories, while in the CDDA we are using all the numbers of the categories. So this type of mapping is mandatory to do. At the level of the transformation into GML, we decided that from the already integrated European data set, that the one final GML file would be too big to be manageable. So we decided to split, to extract to make the transformation per country level. And what we have done so far, those GML files were transformed and tested successfully with the current functionalities of the Hail editor and Oxygen. So we have some level of assurance that we were doing the right thing. However, few identified open issues and difficulties that we found. What is the proper GML coding of multi-polygons, which we have also in the CDDA? Legal foundation document is important to understand. This information is not available in the European CDDA, but it might be available at the national level or at the level of data providers. And the definition of the one attribute as part of the designation type causes difficulties when the data is not known. Difficulties how to provide the correct value. And of course, what we also found in this exercise was that actually we are dealing with two types of voidable reasons. One, it is defined by the Inspire void reason code list, and the other one is used from the ISO standard defining the GML. So, yes. Coming close to the presentation, what were our experiences about the complexity of different steps of this workflow, transformation workflow in our project? The first level was relatively easy. Both data models are defined, specifications exist. They are not big data models, so it was quite relatively easy to study them and to start working with them. The content discussions at the level of conceptual mapping is demanding. It was much more demanding than we expected at the beginning, and we found several issues that for which we had to include additional experts to try to find the reasonings how to deal with them. What is extremely important is to create the proper mapping rules and document everything. The data transformation should become more and more a routine transformation when the mapping rules are completely defined. The level of the validation still includes a lot of uncertainties and maybe risks when we will have availability of the tools that we can be sure to test completely the GML files. And the last one is evaluated as relatively easy as well. So, what do we need? We would need rapid feedback during the conceptual mapping from the thematic experts, and especially from for the interpretation of different Inspire concepts. we would need some more reference examples of proper GML encoding, which would help us to understand what exactly we have to do. We would need clear executable tests and validation tools. And of course, as this development is continuous now, Inspire maintenance and evaluation continues without Inspire MIC. We have also high expectations to keep good connections with Inspire MIC, and we also expect certain support from the activities of the Inspire MIC in this data transformation process. Thank you.
Thank you very much, Darja. Because of time reasons, I propose to move directly to the next presentation. If you have questions for Darja, please contact her over the coffee break. This will start after the next presentation. So the next presentation and the last presentation of this session will be on the Inspire data harmonization and network services at the German Federal Agency for Nature Conservation. And the speaker is Thomas Wojaczek.
Wojaczek, yeah. Thank you.
Okay, thank you.
Yes, thank you. I think, 25 minutes over time, but I think to try it quick. Yes, my name is Thomas Wojaczek from Conterra, and I'm project manager at Conterra in the division of SDI and e-government. And I want to talk about the Inspire data harmonization and network services at the German Federal Agency for Nature Conservation. Let me say BFN, it's much shorter, and because of the time. So the Inspire data harmonization is only a small part of a bigger project regarding the biological monitoring of species in the marine area, and is only a small part of it, a small part at the end of a global workflow from collecting raw data out of observation into the Inspire data model. And I prepare this presentation together with Bettina Dibbern from the BFN and Sören Dubke, but unfortunately Bettina Dibbern couldn't join the conference, and Sören has a parallel track right now, and so I have to do it alone. And so I'm a project manager, and when you have detailed questions regarding the data regarding the transformation part, please visit our booth, and Sören and all the other ETL experts can explain how it works. So, okay, next slide. I will start with a short introduction of the BFN, then referring to the goals of the SDI at the BFN, and want to explain the SDI components and the data workflow. One part of the data workflow at the end is the transformation of the data, of the non-harmonized data into the Inspire data models. And for this, we're using the Inspire solution pack for FME. It's a product from Conterra based on FME ETL technology. And for publishing, we used in this project, because it's placed already, the ArcGIS for Inspire, because SRI technology is placed already since I think 10 years at the BFN. After that, some words about the mapping and publishing process. In this project, we get first steps with a harmonization of protected sites of the Annex 1 topic and the species distribution of the Annex 3 topics. And it's still not finished, so we get fast results of these harmonization steps, and we go on, I think, in the next years with other annex topics, and I think it was a main task for the BFN in the next years to deal with this task. So I finish with the conclusion. So the BFN is the central scientific authority of the federal government for the national and international nature conservation. It's located in Germany, in the German Federal Environment Ministry, and the main tasks are the provision of scientific basis for policy and administrative decisions, the performing of important enforcement work under international agreements of species conservation and nature conservation, the collecting, maintaining and organizing spatial data from the field of nature conservation, like diversity of species, habitats and landscapes. The BFN has its headquarters in Bonn and field offices in Leipzig and on the beautiful island of Smits in the south of Rügen in the Baltic Sea. It's very nice there to make a project. It has about 340 employees currently. So, as I mentioned, the data harmonization part is part of a bigger project dealt with the monitoring of species. And in this context, the BFN realized that they have to renew their infrastructure to deal with all the data coming out from the monitoring aspects. And so the first goal in this context is the modernization of the existing GIS infrastructure. It should be a service-based SDI using standard technology from Esri, Safe Software, and Conterra. The implementation, the second goal was the implementation of a workflow for BFN spatial monitoring data. So beginning from the import of the raw data to publishing results as OGC or Inspire services. Then the simple access to the spatial data via metadata search and web map viewer via intranet or internet based on these spatial network services and metadata services. And the fourth big point was that they have to set up an Inspire node located as at an external hosting partner, because they want to get professional data center operations regarding to the Inspire quality of services they have to fulfill. And from this node, they want to connect to the GDIDE and the MDIDE networks on basis of these OGC and Inspire services. This was a very important point. I hope you've heard the presentation of Johannes Mellis at the plenary. He talked about the MDIDE network, and the BFN is part of this network. So, short view to the infrastructure, to the infrastructure components they use. Let me say it's a typical Esri-driven server infrastructure using ArcGIS for server connected to an Esri geodatabase. On one hand, for the BFN intranet, on the other hand, the same architecture pattern using at the external hosting partner. ArcGIS for server, using for map and features, producing of map and feature services, extended with the ArcGIS for Inspire extension to produce also the Inspire services. In addition, the FME and the FME Inspire Solution Pack, the extension from Conterra for any data upload topics and the transformation topics. On top, we have a map viewer with all these needed SDI functionality, like projection change or add some services coming from the metadata search. A metadata catalog based on SmartFinder SDI technology, also from Conterra, which is installed at the external hosting partner because of collecting metadata with external partners, and they have to get an access to that, and so it's better to install it at the external site. And via reverse proxy technology, the BFN colleagues are also it's also possible for them to access these metadata catalog and to collect data or make quality assurance on this data. Yes, that's the infrastructure. And based on this infrastructure, they process a workflow. The workflow begins with the collection of data through the data providers, and they do it with ship surveys or flight surveys. They count the seabirds, or here I think these nice harbor purposes, like it's a little bit like a dolphin, but with another fin. And they count it, and they count and they generate many other information about these species and where they are located and where they have viewed them. And these raw data, they prepare these raw data in a process, and these prepared raw data, this is they deliver to the BFN. So this is the first step, this is the external step, and the second step is to import these raw data. And we call it then processing data. With the processing data, the BFN is able to produce a map about species distribution or make analyses depending on this data. And if they want to share these results with all other colleagues in the company, they set up a service for example, in ArcGIS for an ArcGIS map services to share this information, to bring it in the map viewer so that the other colleagues can have a view on it. And these result data, and if they want to share these result data to the MDIDE network, they transported it via copy or replica mechanisms to the external hosting partner, and from this node they publish the data to the to the MDIDE or GDIDE networks, and the same process for the metadata, but they collect it directly at the external hosting partner, so that the BFN is able to publish OGC compliant data regarding to map information or metadata information out from this node, and also can publish the data, the result data, internal with the ArcGIS for Server technology. So for this they use, for this part of data harmonization, they will use the Inspire Solution Pack 2.0 for FME. The version 2.0 is currently a prototype. The released version is the 1.2 version, and with this version you have the option to generate an SVGeo database out of these, based on these, based on the data, This is a data harmonization process that produces, say, these SVGeo databases, and the SVGeo database is the origin for the publication of the services, of the Inspire services. In addition to this object, to this option, a second option will develop in the next years. It's called the 2.0 option, and with this option, you don't need a Azure geodatabase, because it's only available for right now for the Annex 1 themes. It's the option directly to transform into a GML and process also the atom feeds you need to write an Inspire predefined dataset download service. This process directly generates the atom feeds for the dataset and the service feeds, and also the open source description file. And this is the second object, and we think it will develop till the end of the year, perhaps for 5 to 10 different annex themes, and then in the next years, case by case, it will improve. So when we publish this data with the ArcGIS technology, we use on one hand the Azure geodatabase, or we use these atom feeds, and we are able to to produce compliant view service based on OGC VMS or OGC VMTS services, both with or without harmonized data, to fulfill the current milestones, the current technical guidances. You are also able to produce Inspire compliant download services from this point, like Inspire feature services on WFS 2.0, direct access and start query, and also the Inspire predefined dataset download services. I mentioned with the atom feeds, the dataset feeds, and the UML file, which was directly produced. So, in addition information, the GeoPortal belongs also to the 10.2 ArcGIS for Inspire, and with this option it's possible to generate an OGC CSW, but it's not part of the project at the BFN. There we use the Contera SmartFinder SDI. So we are able to fulfill all significant objects to meet the current Inspire requirements. And this is one very important point for us, from one very important result at this point of the project. At this point of the project, yes. So, the procedure to publish the data with the Inspire solution pack is the same like we see it in the presentations before. I say we had heard a lot about these tables, these specification tables, these matching tables based on a CSV file or an Excel file, where the Inspire scheme directly could be loaded into these into the scheme on one hand, and on the other hand we have the local application schema definition, in this case in nature conservation areas. And now the task is to, in meetings with the customer, to define the data transformation, the matching and the mapping, and also the transformation specification. When you discuss it, I think it's normal that you have many remarks and some gaps. Perhaps there are attributes not matching, or some attributes are avoidable but very meaningful, and but not stored in the at the source data, and so you have to discuss what you have to do with it. The second part is the mapping process, and the mapping process is also divided, with the Inspire solution pack is also divided into two parts. One part is the individual mapping. This is what you do individual with as a result from the matching table, what you have discussed with the customer, what you have designed with your workbench technology from the FME. And the second part is I say fix in the product. It's a predefined mapping into the Inspire data models. And the result is, in this case, with the Annex 1 themes in this option, directly in S3 Inspire geodatabase, where these results are stored. The last step then is the publishing Inspire view service and the download services, as I mentioned when I talk about the product options. So this is one option we yes, this is one option. We had tested it for the protected sites, and the second one, okay, it's a short slide to publish the service. On one hand, you have the S3 geodatabase, and you have to select the service you want to publish, and then it's the result on the other side where you get the service information. So the second part was the matching and mapping of the species distribution, and it's the same. The data model is a little bit more complex we have to deal with, and there's one step in addition to that. This is the ISO metadata to generate the data sets feeds and the service feeds, also the OTM feeds. In the project, the ISP 2.0, it's planned to provide such a workbench to generate it automatically from a CSW file, and then publishing it as a predefined download service via Atom feeds using the ArcGIS for Inspire technology.
Can you wrap up, please?
Okay, the results of the ISP 2.0 prototype, especially the predefined GML mapping of species distribution, will be used in the further product development. This is a very important point. The product development, I think, will start now and end it perhaps in the end of the year for this new option. We can say that the complexity of the mapping, writing Inspire compliant data structure into GML, is widely hidden from the user. The ISP.0 for FME and ArcGIS for Inspire will complement each other, I think, ideally. There are 2D approaches provided via Esri Inspire Geodatabase and via GML Atom. And so the requirements of Inspire planned for 2017-2020 are fulfilled regarding the Inspire view and download services. So based on these products, data harmonization will be one of the main challenges for BFN in the next year. And we say it's only the beginning of this project. And I think it has to be a lot of hard work in the next year. So thank you for your attention.
Thank you. So I propose that if people have questions, that they contact you at the booth of Conterra downstairs. So I would like to invite everyone to enjoy the coffee break. The next sessions will start at 4 o'clock. Thank you.